All right, thank you everyone for joining. As he said, I'm Nicholas Vidovich. I'm the Deputy PI for DARPA's AI Cyber Challenge from Kudu Dynamics. With me, I've got our entire team who he just introduced, but I just wanted to say that I am incredibly grateful to be on the stage with these people. I've had the pleasure and privilege of working with literally all of these engineers for the last 10 years or more. Incredibly excited to be here to moderate this conversation, and incredibly happy to present them with hopefully some questions that show off their level of innovation and knowledge on the subject, and just the passion that they've been putting into this project and program for the past 2 years. So yeah, super excited, and I hope you'll bear with me. I've got some notes that will hopefully keep our conversation going. Yeah, we're here today with the team that built and ran the most advanced evaluation of cyber reasoning systems ever attempted. The infrastructure, scoring, and challenges set a new benchmark, and because we're open sourcing it all, we're laying the foundation for the future. So that's kind of how we wanted to, focus this conversation. And as they introduced every, one of our engineers here, I'll say Ken Harding, our competitor interfaces lead. We've got John Siliman, our researcher interfaces lead. We've got Jeff Casavant, our maintainer interfaces lead. Isaac Goldthwaite, our challenge design lead. And Scott Lee, our scoring and evaluation lead. Most of these, you heard names like maintainer interfaces and competitor interfaces. And so I wanted to start by asking Ken, how were these teams organized, and why are the teams called maintainer interfaces and competitor interfaces?
Yeah, so when we started working on the final competition, we really wanted to think through stakeholder empathy. That was like the main thing that we wanted to talk about, as well as like real world applicability. So like competitor interfaces was to interface with the competitors, specifically like a SAST or DAST, like static analysis security tool or dynamic, and to be like, what kind of things would that stakeholder think about if they were trying to build one of these systems? Maintainer interfaces is, as the context of a maintainer, would they accept any of the stuff, as a maintainer themselves? So like a lot of the thinking that he was doing and the way he was thinking about problems was with that kind of stakeholder in mind. Researcher interfaces, people are going to get to see the massive treasure trove of data that we've generated from this competition. And as a researcher, how would I want to interface with that? So we really leaned heavily into that empathy, and it really drove a lot of our design decisions. I remember we were talking, I think, about the scoring algorithm, and it was like, okay, well, as a maintainer, would this be useful to you? And we'd be yes or no, and that really helped give us a vision for what we are representing in terms of making something real world applicable.
Nice, thank you, Ken. Yeah, so this idea of having stakeholders in the community, and specifically open source maintainers, obviously with critical infrastructure and the goals of this program of improving security of open source software, really trying to tie into the ecosystem, I really wanted to kind of establish and ask Jeff, as maintainer interfaces lead, how do the CRSs, these cyber reasoning systems, integrate with the tools that exist in the software development lifecycle, and how do they receive the tasks and challenges as part of the final competition, and how does that tie into the traditional software development lifecycle?
Yeah, so we were very focused on making sure that we could integrate with. Sorry, I talk quietly. We were very focused on making sure we could integrate with other tools that are commonly used. In this case, GitHub, right? So when we presented a challenge to a competitor, that was driven by an event on GitHub, a pull request or a release, and we would convert that into one of the various types of tasks that we could send and hand that via our internal custom API over to a CRS, stripping away all the GitHub-specific stuff so that we can then integrate later something like GitLab or being able to upload a folder of code off of your local machine.
Nice. So it's really about integrating into the ecosystem. We've been working with the Linux Foundation, Open Source Security Foundation, like people that are really already working with the maintainers of open source software. And so kind of having the competition work in the ecosystem where they live, already is kind of the foundation. So thank you for that. I guess really what we want to talk about next is probably the challenges. So Isaac, it's kind of a tough question maybe, like how do you design challenges that are fair and also still challenging, especially as we saw technology progress over the past, several years with the large language models and frontier models, and what did that look like for your team?
Yeah, I think fairness is interesting and real-world applicability is also similarly interesting. And I think first and foremost, the big step towards real-world applicability and therefore fairness is basing everything we did on actual open source repositories and actual open source code bases rather than like custom created stuff. And so we have these challenges that are realistic vulnerabilities, many written by actual open source maintainers, put into actual open source repositories, and then demonstrated and proven through actual maintainer-created or at least maintainer-approved fuzzing harnesses as well that are pre-existing for the most part. And so what this means is you have an interface to the code base that the maintainers have already communicated matters to them. You have a CRS able to, through that interface, prove a real crash that's happening. And that being kind of the basis avenue for these challenges set us up for a on one hand, scaling heavily, but also to have like much more realisticness to it. What was the second half of your question?
Fairness, as the challenges pertain to the advances that are coming from large language models over the past couple of years.
One thing we wanted to avoid in particular was having these models create the challenges and then have the models solve the challenges. So, and one point of that is avoiding any sort of like, we didn't use AI to make these challenges, basically. As far as fairness, I think a big thing was the diversity of vulnerability authors. So we had a variety of people, both people from our company as well as several other companies, as well as partners and collaborators and stuff, chiming in and helping create vulnerabilities for the competition. And so there was not a bias based on like what we thought. Another big point of fairness was kind of we've been calling it the firewall that we put up between my team, or the competition challenge team, and the competitors. So we were very diligent to not have what the competitors were talking about in terms of their strategies and what they were doing to bleed over into us in designing the challenges, because we did not want to be biased, even subconsciously, by hearing what some teams were or weren't doing. Which has made this event extremely fun for me, because I basically pretty much have not met the competitors ever because of that. And so it's been really fun to meet you guys. Yeah.
Yeah, I think that's a common theme that we're going to come back to, is this idea of firewalling parts of our team off as we do different activities as part of the competition. So on that subject, I want to ask Scott, specifically, how does scoring work? In this competition, we saw the results were announced earlier, and we see the final scores. But can you kind of explain how the scoring works and why we designed the scoring algorithms the way that we did? Do we have a microphone check for Scott?
Do it closer.
I'll switch to Isaac. All
Gotcha.
right. So designing the scoring algorithm for this competition was
You be a little louder.
a fairly unique challenge. So on one hand, we want to design an algorithm that incentivizes the CRSs to solve real-world applicable problems. So analyzing things like full code bases, or just a delta between a code base and a pull request, for example, or evaluate whether or not a bug report is valid or invalid. Those are the sorts of things that open source maintainers, software developers everywhere are dealing with, every single day. So we wanted a scoring algorithm that incentivizes good capabilities in all three of those areas. On the flip side, we are designing a competition for, what is effectively a team of hackers, right? So we expect that the competitors in this challenge are trying to understand all the nuances of this scoring algorithm in order to gain an advantage, because that's what people in our industry do, right? So balancing those two things, I think, made the scoring algorithm development, a really interesting challenge. And I think the team did a great job kind of threading that needle, coming up with a system that incentivizes all the right behaviors, and made it very difficult to game the system. I don't think we saw any evidence of that happening.
Yeah, that's great. I think I'll open up to everybody. Like, as you looked at the teams that won and the scores that they got, did you feel like that reflected the incentives in the scoring algorithm correctly?
So I think we saw that for sure. I think the teams that were the good at all three aspects of that challenge, finding vulnerabilities, generating patches, evaluating bug reports, I think the teams that did that the quickest and the most accurately were the teams that ended up leading on the rankings board. But I think the aggregate score doesn't necessarily tell the whole story either. We have teams that were very good at 2 out of those 3 things, or 1 out of those 3 things, and may have been better than the teams that scored higher in those specific dimensions, right? So I think every approach had merit, and I think each of the teams, you could tell where they had placed their particular focus, because they might have shined in a particular area of the competition.
All right, great. The next one here is really maybe for Ken. I'll change it up. So if a team's cyber reasoning system, their CRS, or maybe even part of our competition infrastructure went down, how did we make sure to maintain fairness? And did we have any examples of that, like during either the exhibition rounds or during the final round?
We keep trying. So if a team didn't get a task when we tried to send it, we keep trying to send it throughout the entire duration of the challenge window. And we expect the same thing from a CRS in return. If our infrastructure goes down, we say, keep trying, just keep retrying. Like, it's that's real world. Stuff goes down all the time, and systems need to be resilient to that. So we really were leaning into the real world aspect of that.
Yeah, and the whole thing really is about keeping fairness and making sure that we can actually score this objectively after the fact. None of what we're doing in scoring really is subjective, and that's a major part of the scoring algorithm here. So I think I want to change gears. I know we've got maybe 10 minutes or 15 minutes left, and kind of talk about we've got tons of time apparently. Great, we could talk all night. But I do want to change gears and kind of talk about what we call crumbs. So this is an acronym for Cyber Reasoning Unified Model Benchmark System. And this is where we're going to open source basically, all of the software for the CRSs, but also open sourcing all of the data that's generated. So John, specifically, I'd like, could you describe kind of what data, people can expect to see in that archive, and ultimately, what kind of tools do we want to build around that?
Yeah, so teams sent in telemetry of while their CRSs were running. They were free to report whatever they wanted, more or less. But we have LLM requests. We have what the CRSs were working on at different times, tied back to tasking they were working on. So in that data, you're going to be able to see, for at least some of the teams, the approaches they were taking to different problems, the prompts and completions to the different models that they were communicating with.
Yeah, this includes the challenge repositories as well.
Yep.
And maybe for any of you, like whoever feels the strongest, why is this such a big deal in the cybersecurity research community?
And, I think it's a large set of data. It's going to have several million prompt completion pairs from the models, tying that all to the submissions from the different CRSs. It's a big data set. It's unique data that you're not going to find anywhere else. And I think it's going to drive a lot of, there are a lot of interesting questions that researchers are going to be able to ask of it. Just kind of figure out what the different CRSs did well. Hopefully be able to kind of figure out, I mean, like Scott said, like some teams were really good at one particular area, other teams were good at others. Hopefully through some of this data, people who continue on in this research will be able to grab some of that and start mirroring techniques and figuring out where resources are more efficiently allocated, if it makes more sense to spend LLM resources generating fuzzing inputs, or there's a whole bunch of questions that people are going to be able to ask and answer, and it's going to be really cool.
So I want to just add something quick to that. Sorry, Jeff. I was talking to one of the teams a couple days ago, and they said something I thought was really interesting. Everybody here knows the concept of Patch Tuesdays. They introduced me to the concept of Model Mondays, which was a day that they used to take all the new model releases and reevaluate their system against these new models. And I think what we've seen as new models come out, everyone is really interested in these evaluations. How does this model compare to the last version of this model or this other model that was released yesterday? I think what Crumbs and what this data set represents is another opportunity for that evaluation to happen, right? I think that'll be our contribution to the state of the art here, so we can develop new model benchmarks based on the data here. Model Mondays will hopefully operate on some of the AIxCC's Crumbs data.
And I think some of the data will be useful for fine-tuning models themselves, contributing back I imagine that some of the model providers are probably would take some of this data and incorporate it in their own training data sets if they want to have the best of the best model for security research.
To some degree, I think we've covered it already, but I am very interested to see the relative performance of the different LLMs that were used, including open weights models. That'll be particularly interesting. And then also, I could have sworn there was a second thing in my head. It was prompting strategies. I'm very interested to see how the different teams prompted their chosen LLMs to produce good patches.
I think in the data too, you'll be able to ask and answer the question of is it better to use smaller, faster models? Is it better for certain areas? There's just going to be a whole bunch of questions that creative security researchers are going to be able to dive in and figure stuff out and hopefully drive future research in this area forward.
And I think everything being released open source too, the challenges themselves, and of course I'll have Isaac weigh in on challenges, but people can build their own, competition out of this to evaluate. It can be a benchmark for the future. I think there's a lot of downstream effects that we can't even yet imagine from this being released open source.
Yeah, I wanted to speak on that too. I don't technically know if it's considered crumbs or not, but the fact that we're open sourcing our tools as much as we possibly can about the competition, even this is day one, and I've had I think 3 people ask me how can I join this competition? And the first answer is you can't. It's over. But that's kind of right. In reality, all of the tools that we built to make this competition and run them will be available as far as I know, and that is if you want to use those tools to then build your own system and run your own system, you can do that. And not only that, but through the release of the challenges, you can see how we made challenges. So it's like, do you want to make your own challenges? You can do that. And then rerun those challenges that you created against your own models, your own CRSs, and just the ability to take the orchestration we've created and hand it over to the community and let them just play with it and do what they want and help expand on that, I think will be really cool.
Awesome. Well, thank you for all joining in on that. I think I've got several sales pitches here for the archive itself, and I think we'll probably just want to tell you some of the tools that are going to be included with that archive: the ability to query the data, the ability to download all of the associated data, all of the challenge information. The other sales pitch here is for the actual infrastructure that our teams have built for running the competition, for generating reports, for looking at the data itself, for building challenges, as Isaac was saying. And that kind of leads into my next set of questions, is really about the scoring pipeline, as we call it, and the architecture for that, the consistency and accuracy of that scoring pipeline, and then being able to extend that with additional challenge design and development. I guess, what are the implications of that going forward from your perspective?
So the scoring pipeline, that operates on an artifact that came out of the rounds that we call the audit log. So every interaction that a CRS had with the competition infrastructure was logged, and that log becomes part of the crumbs data set. The scoring pipeline ingests that log and scores based on those artifacts. Right? The implementation was based on a document that's available on AIcyberchallenge.com called the Procedure and Scoring Guidelines. If you're interested in the details, I suggest you download that and read through it. But we had to implement to that specification. That was a document that was very thoroughly reviewed, was developed to incentivize the proper behaviors within the competition. So we did that was our specification. We built a scoring pipeline around that. In order to gain confidence in that, we also implemented a CRS of sorts. It was a CRS that could replay known good answers and known bad answers to challenge problems. So with that, anytime we would task that CRS with a competition challenge, that CRS would respond with a provably good or provably bad result. So we could use that to generate an answer key, and we could use that answer key to compare the results of the scoring pipeline implementation against that known answer key. We did some other things to build confidence there. We did a second white room implementation of the scoring pipeline with a second team to verify that we had captured all the edge cases correctly. So I think a great deal of care and attention went into building the pipeline based on a faithful representation of that procedure and scoring guide. As far as how that can be extended going forward, I think when the code is made open source, I'll be very interested to see, if the community decides to adapt that to potentially score different types of artifacts. I said before that we were looking for proofs of vulnerabilities, we were looking for patches, and we were looking for Seraph assessments. What other scoreable artifacts is the community going to want to enhance that scoring pipeline with? And we'll see those tools get applied in a broader way in the future here.
Cool. I think an open question might be, how can people get in touch with us? Or how can people get involved, really? And so if I'm thinking, I'm a company, for example, and I'm developing my own software, can I use these CRSs to improve the security of my first-party software that I'm writing? Or is this just for open source and the dependencies that I have in the software that I'm writing? So those might be some open questions that I don't know if anybody would want to. Yeah, go ahead. Go ahead, Jeff.
Yeah, sure. So our internal API to talk to the CRS is not really dependent. It's defined on its own in isolation. And you provide the artifacts via blob storage, HTTP GET request, right? So you can run one of these CRSs and task it without bothering to set up all the other different pieces that we had to in order to make the competition run properly. So yeah, big win there.
Yeah, I wanted to ask you specifically, like if we wanted to rerun this entire competition round again, how difficult would that be? Or could we do it today?
I would say reasonably. I don't have a
Reasonably
whole lot more
difficult or
to-
reasonably easy?
reasonably difficult.
All right.
Yeah, there's a lot of moving parts there. So, and a lot of stuff that we've spun down to save costs since then.
That's
so.
fair. That's fair.
Yeah, we had a whole game runner engine framework that, like, the way we actually kicked off challenges is we submitted pull requests to GitHub. And a GitHub app that was installed to it took those GitHub events and tasked the CRSs. Like, you can't get any more real world than that. Or we created a GitHub release, and that generated a full scan challenge to all the CRSs. So, like, a lot of that will is provably, like, based on real world events. Like, a team could go build a GitHub app tomorrow that integrates with their CRS API, and that could be a product that they could implement into the GitHub app marketplace or whatever. But as Jeff said, it's just a matter of implementing the API spec, and it could, the winning team can be used today. Like, it's open source, so it's very cool. Archive.aicyberchallenge.com is where we've got links to all those CRSs, so you can get started with it today.
You also mentioned, like, is this just for open source? And the competition was obviously based on open source, but a design decision that I am, like, in awe of more and more as things have rolled out, that was not mine, but I think Jeff's or someone's, was the fact that, yes, we are running this competition through, like, events generated through real open source software like GitHub, app picking it up, targeting the CRSs. But the CRSs are working on code bases with no care about GitHub and even no care about Git. So, like, the actual challenges themselves aren't, when the CRSs are holding them, are not operating on Git history, they're not operating on things. And what that means is these CRSs can operate on any software you want them to operate on at all. Private software, open source software. Oops, I copied a folder, I don't know what the difference is or something, I don't know. Def the two folders and you can run a CRS on it. It is very extensible from their perspective because they're just working on code in a basic form. And then those building blocks to be like, it can auto-run from GitHub, it can auto-run from GitLab eventually, and things like that. I just think that's awesome. It's very cool.
Nice. We've got just a couple minutes. I know there is another talk at 5, so we're going to keep going. But I am interested in, now that this software is open sourced, where do you want to see the CRS technology go from here, or what are you hoping to see? Maybe we can go down the line.
Yeah, I'm happy to take a first stab at that. So part of what we did within scoring was build, effectively a internal CRS to dog food some of these interfaces. And what I found in that experience is, at the beginning of the competition, that was a fairly complicated agent that we had built. As the competition went on and models got better and better, we ended up throwing complexity out and simplifying that implementation. So I think, what I expect to see as we go forward, as models get better, I think the infrastructure and the framework you need to put around the model is going to get smaller and smaller. And I think at some point we'll get to the point where the models can do it all on their own.
There are a lot of guardrails that are necessary to run a competition that can be objectively scored, and I'm really excited to see what happens when we can pull those off and as these LMs get better, and as these CRSs get better. For example, like, we operated this competition on a standard interface and provided, we jumped on top of things like Google's OSS fuzz to help provide, like, standard ways to build and harness and run things. But in reality, like, we could allow the CRS to be like, hey, here's just a code base. You figure out how to build it. You figure out how to run it. If you want to use a harness, go for it. If you don't, whatever. But just, like, I think the future in a large way is a maintainer or whoever defining, this is the information I want to receive in the form I want to receive it. And everything else is, like, on the responsibility of those CRSs to figure out. And I think if the technology continues to improve, it will be, like, really cool to see that roll out.
I'm personally very interested in the practicality of everyday use of these CRSs. So we obviously drove the challenges off of releases and pull requests. It will be nice to see them speed up and be able to run with lower cost models, run on less hardware, so that individuals can run them and get quick feedback on PRs.
Biased, thinking about data. I'd love to see. I'd love to continue to play with the data, see other people do it when it's released, and to figure out, what things the different CRSs did efficiently. I'd love to see the different parts of the different good parts of them married into some super CRS that's almost immediately better than what was the best in the competition. Just see that whole area move forward quickly.
Yeah, and in terms of the competitor or the SaaS-DAST vendor scenario, like I hope that competitors take their CRSs and make GitHub Actions workflows around them to productize them, because that it's really incredible technology. Like I want to run it on my code bases. I want to a CRS can handle Wireshark. Like that's insane. Like that's 5 million some lines of code. Like this is some really impressive technology that was developed, and I think there's a ton of opportunities for it to spawn new industries that can really help out security researchers and also critical infrastructure.
Yeah, I agree with that actually a lot. I think we were maybe surprised to see 77% of the synthetic vulnerabilities were able to be discovered. So I'll just jump in and say that I'm looking forward to seeing more languages being covered, but also more challenges being developed and added into this kind of corpus. If you're familiar with the last human test, and they're testing LLMs to see can they solve these 1,000 problems that are really hard for all of the smartest humans. I kind of foresee we'll have the last human cyber test or the last AI cyber test that is just really difficult challenges, and can the models actually solve these things over time? And that's really where we're going to be measuring over time to be able to see, can these models actually improve to the point of full autonomy and fully solving all of these security challenges. All right, well, I think that's about our time. We've got 3 minutes until the next talk, so I just want to thank all of you again. Once again, I've just been really, really happy to work on this program with you all. Incredibly impressed by the engineering skill and leadership that you've all shown on this program, and I think it really comes through in the relationships that we've built with competitors, the relationships that we built with open source maintainers, and hopefully, the longevity of the open source software that our team here has built, that all of our competitors have built, and the overall ecosystem that we hope that you all, are going to join in and be a part of. So thank you. And thank you all for joining as well. Super happy to have you all here, and we're happy to talk with you, at the AI Cyber Experience here all week, or all weekend. All right, thanks everybody. Appreciate you.
Thanks, Nick.
Thank you.